By the way, no one really memorizes it. Like I've never had any of my students say, "Oh, yeah, Sam, I just use the remainder theorem. Or I just use the factor theorem." You'll start to realize they're all pretty much the same thing, right? The logic is you got to solve, you sub it in, gives you a remainder. That's essentially the logic. But hold on. The factor theorem. What does the factor theorem say? All right, well, let's read what the question is asking firstly. In each of the following, show that the first polynomial is a factor of p of x, and hence find all the factors of p of x. So this is a factor of this polynomial. So the first polynomial, maybe x plus 1, is a factor of this. All right, for it to be a factor, maybe I should say it like this first. Before we do this, right? Give me some factors of, I don't know, 8. Give me the factors of 8, the number 8.
1, 2, 4, and 8.
Good. 1, 2, 4, and 8. Okay, how do you know these are factors of 8? 1, 2, 4, and 8. What defines these as factors of 8? Why? Why specifically are these numbers factors and not, for example, let's say the number 3? Why is 3 not a factor?
Because
because it isn't. There has to be a word that we've learned in polynomials that you go, yeah, that's why it isn't. Sorry, go ahead.
Oh, because if you do 8 divided by 3, it's going to be a decimal.
Yep, and we haven't used the word decimal in this topic. There's a word that we've used. I mean, how many words really have we learned? Not many. To think, what word am I trying to say? Say it again.
Divisor.
Oh, yeah, keep going.
Remainder.
Yes, that one. Remainder. You said it, Darius. You said there's going to be a decimal, but we didn't use the word decimals. We used the fact that there's going to be remainders, right? If we did 8 divided by 3, it's fine. You can divide it. No one's stopping you. But because there's a remainder, it is not a factor, right? So for something to be a factor, it must go in it fully without any remainders. So let's just quickly write that. For something to be a factor, no remainders. So, oops. For factors, you should not have any remainders. Does that make sense? All right. So who can put what I just said there, and possibly what we've learned already, maybe in Unit 6, to answer this question? In each of the following, show that the polynomial is a factor. How am I going to show that this is a factor of this?
Divide.
Put it together. Without division, yeah, you're right. Without division, if we can save a few lines. Unit 6, whatever we just did, maybe.
Substitute.
If it helps. Yep, so what would you do? Don't just say that word, tell me the steps. Be specific. Solve this. -1. Sub it in. Sub that into there. What must it equal to? Anthony, without doing the math, what must it equal?
0.
Why? Why must the remainder be 0? Because I'm trying to show that it's a
Factor.
right? 2. When you do 8 divided by 2, are there any remainders?
No.
No. So that's the logic. But how do we do that here? We just solve, sub it in, and then if he gives you a remainder, then it's not a factor. So like these guys, this x plus 2 is a factor technically, right? Because the remainder was 0. X minus 2 is not a factor. These ones all are not factors because there's remainders. Does that make sense? Danya, is that clear? Am I making sense?
Yeah.
Yep. So again, with the next one, with B, what are we going to do to show that x minus 1 is a factor? Say it again.
Sorry, do we have to solve these though?
Well, you're just solving this bit if that's what you mean. But are you trying to say solve as in use the whole long division?
As in for question 1, we have we've written down, I don't know, the equation essentially. Would you have to solve it?
No. So just says show the first polynomial is a because it says hence find all the factors. Yeah. I'm not answering the second part. Is that what you're saying? No?
Yeah.
Maybe. Look, for now, I'm just answering the first part. So show that the first polynomial is a factor. So the way we show it's a factor is, we've got x minus 1, sub it in, you get 1 cubed plus 1 squared minus 5 plus 3. 3 plus 1 plus 1 is 5. 5 take by 5 is 0. Therefore, x minus 1 is a factor. The part that it says hence find all the factors, there's only one way to do that. Anthony, when you know 2 is a factor of 8, how do I find what 8 divided by 2 is? Oh, how do I find the other factor of 2? Sorry, blah, blah, blah. How do I find the other factor of 8 that's
We divide.
2? Yeah, I was trying to say it in a way where I didn't say the answer, but I couldn't. Yeah, pretty much you're just going to do 8 divided by 2. So there's only one other way of finding the other factors. It's by actually dividing. You can't get away with that. You need to find other factors that we're talking about, we're talking about this. We're talking about this number on the top. There's no other way other than long division. I'm not worried about that because that was last week. I'm more just trying to run through what we are pretty much doing today. So what's the solution for C? What am I going to sub in? What am I subbing in?
Half.
Yep, you're right. And then look, Anthony, you'll know if it's right or wrong because you're trying to show that it's a factor. If by accident you subbed in, negative half or 1 or whatever, you realize it won't work. But go ahead and sub in half now into your calculator. All right.
Gives you 0.
Gives you 0. Good work. It has to. It must. It must. All right. So now we understand the factor theorem. Like I said, can you see why I personally said I hope you will realize that they're all linked. It's essentially the same concept. The remainder theorem says you can sub it in and you'll find the remainder. The factor theorem says you can sub it in, but if it specifically gives you 0, then it's a factor. That's all. So they're pretty much the same. All right, I'm going to move down. But let me know if I'm going too fast. I just want to see what's left. Instead of the polynomial, show that this is a factor. Maybe next week, and then we'll wrap it up. Maybe I shouldn't go too fast. Solving equations. Yeah. All right, I'll leave it there. But now, let's do some classwork and make sure we're good. And then if I see we're all right, I'll move on. So I think you guys get question 2. Let's just do literally these 4 questions.